Hey, this is Presh Tallwalker. A version of this problem was used as an Amazon interview question. A cable of 80 meters is hanging from the top of two poles that are both 50 meters from the ground. What is the distance between the two poles to one decimal place if the center of the cable is A, 20 meters above the ground, and B, 10 meters above the ground? Now, to be more specific, a version of problem B was asked during an Amazon interview. But I've included problem A because it's interesting mathematically. Can you figure it out? Give this problem a try, and when you're ready, keep watching the video for a solution. So let's solve the case of 20 meters above the ground. We have the ground, we have two poles of 50 meters each, and we have a hanging cable that's 80 meters long. The center of this cable is 20 meters from the ground, and we want to solve for the distance between the two poles. Now, I'll admit I had forgotten how to solve this kind of problem, so I had to look up some formulas online. Many of the websites referred to the physics interpretation, which involved weights and tensions, and I just wanted to get to some of the mathematical formulas. So I found a great reference from Chatterjee and Bogdan Nita, the hanging cable problem for practical applications in the Atlantic Electronic Journal of Mathematics. I provided a link in the video description, and I recommend you check it out. So we'll solve this problem using symmetry and a convenient coordinate system. First, we'll split up the cable into two lengths of 40. Next, we'll consider only the distance from the center of the cable to one of the poles. We can then double that distance to get the distance between the two poles. We'll also use a convenient coordinate system that's centered at the center of this hanging cable. In other words, the y-axis goes at the center of the cable, and the x-axis also goes so that it's just touching and tangent to the center of the cable. So we want to calculate this distance x. From the paper, the general catenary equation that's tangent to the ground or the x-axis takes the following form. Y is equal to a cosh of the quantity x over a minus a. Furthermore, the top of the pole in this diagram will be at the coordinate x, 30. So we can use the point at the top of the pole to get one equation. This simplifies to be a cosh of x over a is equal to 30 plus a. It'll be convenient to divide both sides by a. So the cosh of x over a is equal to 30 plus a all over a. Now we have another equation which is using the length of half of the cable. This equation will be a times the sinh of x over a is equal to the length of 40 meters. We'll again divide both sides by a to get the sinh of x over a is equal to 40 over a. Now we can use the hyperbolic identity that the cosh squared of t minus the sinh squared of t is equal to 1. So we substitute in the values we've just derived, and we can solve for this value of a as a quadratic equation. We get that a is equal to 35 over 3. We now figured out this unknown parameter, and we can then use it in our second equation with sinh to solve for the value of x. And we end up that x is approximately equal to 22.7 meters, which we will then double to get the distance between the two poles as 45.4 meters. Amazing. So now, how do we solve the next problem? What if the cable is only hanging 10 meters above the ground? Now suppose you try and go through the same exact method. At this point, the top of the pole will be at a point x, 40. So we'll use the same equations and we'll substitute in the new values from this particular case. Now when you substitute into the hyperbolic identity, you get the following equation. And if you try to solve it, you run into a problem. This equation has no solution. So what is going on? Well, we're going to need to think about this problem logically. The hanging cable is supposed to be 10 meters off the ground, which is 40 meters from the top of the pole. But half of the cable is already 40 meters. In other words, the cable must be folded exactly in half. And that means the two poles are coincident. They are 0 meters apart. So our diagram is actually going to look like the following. We don't actually have a hanging cable between two poles. We actually have this cable is going directly down from the two poles because they are exactly at the same spot. No equations required. Many employees can mindlessly calculate the answer, but how many will think before they calculate? And to be honest, I completely missed this problem because I didn't see the trick. But I like to make videos about these problems because it's like the old saying goes, fool me once, shame on you. Fool me twice, you can't get fooled again. Thanks for watching this video. I post math videos that can be watched for free with topics from people around the world because math is universal. If you'd like to help with the cause, please subscribe for free to get the newest videos. Watch and share all of Mind Your Decisions videos so that more people can discover the channel. Email me a math topic or puzzle at presh@mindyourdecisions.com. Check out my books, which are linked in the video description. And if you want to support that math is universal, please support financially on Patreon. Thanks for watching, and thanks for your support.